So there's a new open-source AI model out there, and honestly, it's making some serious waves. We're talking about a model that's going head-to-head with the absolute best proprietary systems in the world. Today, we're going to break down the research behind this thing, DeepSeek-V3.2, and figure out if it's really the game changer everyone's talking about.
All right, let's just jump right in, because you have to start with the headline result. And it is genuinely stunning. A special, souped-up version of this open-source model just scored at a gold medal level on problems from the International Mathematical Olympiad. We're not talking about easy stuff here. This is one of the toughest intellectual competitions on the entire planet.
And that brings us to the big question, right? How is that even possible? I mean, for the longest time, everyone just assumed this kind of performance was only for the giants. You know, the huge, closed-source models with basically unlimited resources. So how on earth did an open model make such a massive leap?
Okay, so to really get this, we got to understand the problem DeepSeek was actually trying to solve. See, they weren't just trying to build another AI model. They were trying to close a really critical gap that was forming in the AI world.
And here's the context, which is super interesting. The folks behind the paper noticed something was happening. Open source models, yeah, they were getting better. But the big, closed, proprietary models from places like Google and OpenAI, they were accelerating way, way faster. That gap between them wasn't shrinking. It was actually getting wider.
So they basically zeroed in on three major roadblocks. First up, the standard architecture just wasn't efficient, especially when you fed it a lot of text. Second, the open source community just wasn't investing enough computer power into what's called the post-training phase, and that's super crucial. It's where the AI really learns to reason. And third, these models weren't great at being agents, actually using tools to get complex stuff done.
And that's where this all comes together. DeepSeek V3.2 was built from the ground up to smash through those three roadblocks, with three really powerful innovations.
First, they changed the architecture. They built something called DeepSeek Sparse Attention, or DSA. The best way to think about it is like a super intelligent speed reader. Instead of getting bogged down reading every single word in a huge document, it just knows how to find the important stuff. So it can understand a whole book or a dense contract way faster and more efficiently.
Okay, second, they tackled that investment problem head-on. They built a new system that let them just pour a massive amount of computing power into post-training. We're talking more than 10% of the entire initial training cost. And all that power had one single goal, to make this model's reasoning skills razor-sharp.
And for that third problem, making it a better agent, they built a system that basically created its own homework. It's a pipeline that spat out over 85,000 super complex and varied prompts, all designed to teach the AI how to use tools, how to plan, and how to actually follow through on multi-step tasks.
And this right here shows a brilliant part of that agent training. They gave it a better memory, basically. Instead of forgetting its train of thought after every single step, the model can now hold on to its reasoning as it uses different tools. So it doesn't have to do the same work over and over again, which lets it tackle way more complex problems.
So, okay, these three innovations sound awesome on paper, but did they actually work? Let's look at the results.
And the results are, wow, just spectacular. On another really tough math benchmark, the souped-up version, DeepSeek V3.2 Special, doesn't just compete, it actually edges out the other top models mentioned in the paper, which they call GPT-5 High and Gemini 3.0 Pro. Think about that. An open-source model is at the very top of the list for elite math reasoning.
And here's the kicker, the part that makes this so huge. It gets this incredible performance while being way cheaper to run. Because of that new DSA architecture we talked about, the cost to process 1 million tokens, which is a lot of text, dropped from $2.40 all the way down to just 80 cents. That's 3 times cheaper. That is a massive deal for anyone who wants to actually use this stuff. But look, benchmark scores are one thing. They're just part of the puzzle. The real test is how these things perform in the real world, right? In live, unpredictable situations. And well, this is where the story gets even crazier. This slide right here, this is the moment that made the entire AI community just stop and stare. They tested that Speciale version against the standards of 4 of the most prestigious math and programming competitions on the planet, and it hit gold medal level performance in all of them. This isn't some lab test. This is a model performing at the same level as the smartest humans in the world. Okay, but let's be real. There's a trade-off here. It's important. To get that absolute top-tier performance, this model has to kind of think harder. It generates more tokens to reason through the problem. So for example, on one test, it used 23,000 tokens to get its answer, while a competitor like Gemini 3.0 Pro used only 15,000. So you're making a choice. Do you want absolute peak performance, or do you want more efficiency?
So let's step back for a second. What's the big picture? Why does one powerful open-source model like this matter so much? What does this all mean?
Well, the creators themselves said it perfectly. They called it a milestone for open LLMs. What it proves is that you don't have to be a giant corporation to build top-tier AI. These cutting-edge abilities can be developed and shared out in the open. And for developers, for researchers, for you, that means getting your hands on state-of-the-art tools without a crazy price tag. And that could unleash a whole new wave of innovation.
But to be fair, they're really upfront about its limits. It's not perfect. It was trained on less data, so its general world knowledge isn't as broad. And like we just talked about, there's that token efficiency trade-off. And yeah, on some of the absolute hardest, most complex tasks out there, it's still not quite at the level of the very, very best closed models.
And that really brings us to the final thought here. You have an open model that has climbed to the very top of some of the hardest reasoning challenges that exist. Yeah, performance gaps still exist in some places, but this achievement just completely shakes up the idea that the best AI can only come from a closed-off lab. And it leaves us with one heck of a question. Is this the beginning of the end for the dominance of closed proprietary AI?